You see my screen there, yeah?
Yep.
Okay, so I'm just going to click into where the link then. I just paused for a second there, right? Can everybody hear?
I can't hear the video, Frank,
Can't hear the video.
from
Do I need to
playing.
go into something else?
I think I want to say there's a check mark when you share your screen.
So Frank, while sharing your screen,
Yeah.
Yeah, when you share your screen, there's an also share tab
Okay.
audio.
I'll just stop sharing for a second and I'll share again. So share screen.
And there's on that screen, there's a share audio, system audio or something.
So it says, yeah, it says follow the steps to share the video and audio, yeah?
Yeah, I think so.
Yeah. Okay, share screen present. It's given me. Okay, so I'll try that again. So also share audio tab. Is that the one, Dan?
Yeah, I think that's if you tell it to share the audio checkbox, that should if you're playing on a YouTube video or a video sound on your computer should get shared through it.
Okay, so we'll try it again. So
you can see your screen.
You can see my screen.
Mm-hmm.
Okay, cool. So we'll just bring that up and just go back to the start.
Hello guys, my name is Joseph Afeso.
Could you hear that?
Yep.
Okay. So I am a Microsoft MVP and I'm very happy to come on the screen again today to walk us through agent settings in M365 Admin Center. In M365, agents can access data, automate activities or actions and act on behalf of users. So controlling who can create, manage, or access these agents is essential to protect sensitive information and prevent misuse and ensure that the agent operates securely and in line with organization policy, right? So agent setting M365 is becoming essential because if you check your Entra Admin Center, for instance, the list of your users, you would see a particular column there that will tell you is agents no or yes, right? So this means that agents are now classified under users, but of just a distinguishing factor here that shows if they are agents or not, right? So it becomes important that we are all aware that agent is coming with the same or even a greater force than AI is being embraced and utilized today. So there will be need for us to manage how we could allow agent usage in our environment and what type of agents do we want, right? So that's why when I picked up this document, I saw a lot of beautiful things that I need us to theoretically look at in the Microsoft Learn document and see how we can also go to the M365 Admin Center to bring up a lot that could also be of use to us. So the agent setting page in M365 is a very interactive page, but the overview, first of all, is that agents, you need to talk about the allowed agent type. So specify which categories of AI agents you want to permit in your organization, right? So we talk about the sharing. So you want to manage who can share the agent within your organization and define the method they can use to share these agents, right? So we speak about the templates. What templates do you want? You want to create a preset policy, the rules, and the allowed list for new agents to ensure consistency and also compliance, right? So talking about the user access, which for me is one of those very important things to look at, because you really need to control which users or groups can interact with AI agents. So aligning access within organization rules and permission. So a lot have been spoken theoretically. Now it is time for us to look at the admin center. So if you look at the admin center here, if you are new here, it is, I've just click on home again. If you are new here, this is actually where you get to. If you type in admin.cloud.microsoft, or if you go with admin.microsoft.com. So if you have the required rights, you would see the agent icon here, and here you have overview, you have allowed agents, you have tools. But as our topic for today implies, we are talking about the agent settings. So we're just going to come into the settings icon here, and at this point you will see how to manage everything relating to agents. So these settings will include control to data access, to user permission, to integrated policies, and customization of agent behavior to align with your enterprise standards. So that's why this is very key, right? So if you come here, the first one is the allowed agent type. We specify which agent category, such as shared, external, permitted for use within your organization. Talking about the sharing, right? For sharing, you will want to manage who can share agent within your organization and define the method that they can use in sharing that. So if you come into the sharing parts, you would see that you can manage who can share, right? So you can decide to say, you know what, I want to allow everyone to be able to share agents, okay? So you can decide to say, I don't even want anyone to share agent, depends on you, or okay, you want to specify users or group that should be able to do that. So we are still going to look at this in detail when we go down to user access, okay? So, and then for templates too, you can decide to create a preset policy, rules, and allowed list for AI agent. But what interests me a lot more is the part of user access, because of course, like I showed you from the Entra Admin Center, agents are now being embraced with 3 hands, right? Not even 2. So there will be need for you to be extra careful of who you want to grant access to agent. The reason is because agent has access to your data, and then it can automate actions, right? And it can do that on behalf of users. So you should be careful who you want to give access to agents to, right? So if you come to all users, which is the default setting that everyone is going to have access to, so long you have the Copilot license, right? So you can decide to say, even though you have the Copilot license, please, I do not want you to be able to create agent, right? Or we can decide to say, no, you know what, we want to specify users. So who can do that? You can decide to type in username, right? Just to bring the user up on the list, like adding one user, right? That is possible. You can also decide to say, you know what, you want to add group of people in a group that you want to give them allowed access to agents. I know I have group that is allowed agents, so I'm just going to create a security group from Entra Admin Center. At this point, I will want to just call it allowed agent 2, right? So because I know I already have created, during the course of my preparations for this video, I have created a group called allowed agent. So I'm just going to call this allowed agent 2, right? So, and I want to leave it as an assigned group. I can decide to make it a dynamic group, but that's not a topic of discussion for now. So I'm just going to copy this this group name, and then I'll just hit on create, right? Just so the group is created, and when I come to the the M35 Admin Center, I can decide to put in the name of that group here, and hopefully that's synced already, and then we can just bring it here. That means that you can put a list of users and groups within here. But I think it is better that you have your controls in terms of grouping, just so that group is more descriptive, and then you practically manage the access to agents by adding or removing users from that group, right? So just click on save and that is created. So this is important, that you manage users that should have access to agents, because of how sensitive it is for you to use. So while you are adopting AI, you are adopting co-pilots, you're adopting AI agents in your environment, you should also be mindful of the integrity of your data, so that you don't have any form of data breach. So I hope this is educating enough. If you have questions, of course, you can drop them on the comment section, and I'm really very happy to engage with you and have the conversation around these topics. So I'll be dropping the link to this document also on the comment section, just so that you can have a look at the Microsoft documents that also discuss this topic. So I'll be saying bye from here, but I hope that we will engage more on the comment section. Have a wonderful morning, afternoon, or evening out there. Cheers.
That was cool, Frank.
Yeah, that's the first time now we had a recording.
That worked really well.
Yeah. So one of our other speakers, Samir, he's in India, and he booked it on Sessionize, but he sent me a video, so I might just play that as well.
Okay.
Because he was on the list. Be a bit of practice. Joseph, that was very good. And
the other thing you can do, Frank, is if you upload the video to StreamYard, if the video is short enough, you can actually just play the video and it'll go full screen in StreamYard, and it'll mute all of us.
So
I think you do that under media assets on the far right.
Okay, so I'll just download it first.
Yeah, you have to download it, and then I think it's under video clips.
Okay.
And I don't remember what the length restriction is, but there was like a way to upload it as a clip. I know that's how Matthew used to do like the 5-minute or 3-minute breaks and stuff.
Okay, so I go into the media. Is that
we used to have on the Journey to the Cloud show? Yeah, I think it's media assets, and then there's a video clips area, and I think it'll tell you if there's room.
Oh yeah, I see intro and outro.
Yeah,
there's more.
Yeah, I don't remember if there's a limit of like a certain length, and then there might be. There's also under the plus where you go to share your screen. There's a video file under there too. So I don't know if you need to upload it to the plus video file or to the intro outro.
Okay.
But it'll probably tell you what the length limits are too.
Hi everyone, thanks for joining me today.
There we
my
go.
name is Samir Maistikar, and I'm the 2 times Microsoft MVP. Firstly in Happy Crowd, and now in the Microsoft AI services. So today we are going to talk a little bit about monitoring Azure OpenAI service. Now this is going to be a quick introduction to not how to do it, because I think in a lot of YouTube videos or in sessions in conferences you may have already seen in the portal where to go, what to click, and how to configure things. But here I'm just to tell you some of the things that I've learned over the time from my experience, or watching other people do it and learning from their experiences. So this is going to be a little bit of I wouldn't say theory, but a lot of discussions, prep. Let's call it the prep before you actually create or set up some monitoring. Now, that's what we're going to do. Agenda today is to discuss why Azure OpenAI monitoring differs, Gen AI monitoring in general is, if you're in this domain, you must have realized is not exactly the same thing. So we are going to discuss why and what. Then we are going to talk a little bit about the official Azure monitoring approach. Azure has an amazing observability platform called the Azure Monitor. So using that, if you're deploying in Azure, then it becomes easy for you to get started with your monitoring. But then we also have some gaps in this monitoring. So this ecosystem is constantly evolving. So we haven't reached to the end game yet. So we still have a lot to learn, and Microsoft also is trying really hard to give us the ability or the power to monitor our apps to the best. But still, we are getting there. We are not there yet. However, there are some third-party tools and frameworks that are very widely accepted, and that they do, enhance your capabilities, or give you the power to go a little bit deeper into your application or your LLM layers to monitor your telemetry. Then we are going to quickly discuss what the pitfalls and the real-world lessons that we are getting out of this from the experience of monitoring your OpenAI systems. Now let's talk briefly about what monitoring Azure OpenAI versus apps is like, just traditional apps, what that actually mean. So when we are talking about monitoring an application that is powered by Gen AI systems, then we are really talking about two different observability platforms or two observability systems. So one is the infra-focused, where let's call it the heart of the application, or the body, let's call it the body of the application is running. And then there's the LLM observability, where the brain or heart, or whatever you want to call it, the brain of the application is running. And these things are different. So we've known for a while about the infrastructure monitoring, infrastructure observability, but the LLM observability part is a bit new for us, and we are still learning what to do and how to do it. And so when we talk about infrastructure metrics, we're really talking about things like VM uptime, CPU memory, network latency, error rates, just to make sure that we are, the performance of the application is reliable, and it is performant for all the users. Again, so we've been doing this for a long time. However, LLM behavior observability is quite different. So LLMs do have their unique personality, right? So every different model that you deploy, a different model that you use, will behave differently and will respond differently to the same exact prompt. So from this personality, it also comes with a lot of nuances as to how an LLM system actually behaves, and how do we determine whether, if it's behaving correctly, or we want to improve the behavior. So we monitor output quality, prompt effectiveness, and conversation flow, detect hallucinations, bias, content loss, context loss. So these are all the new terminologies, new concepts that we've had to learn since the LLM apps are being, are coming more into the market. Combined monitoring, now, of course, when we talk about an application that is powered by Gen AI, we are not only isolated monitoring LLM, but we are also not isolated monitoring infrastructure. So we have to combine them together, because that is what the whole creates the whole application. And then strategic impact, how does this actually affect how the SLAs are to be defined and are to be maintained? How do we continuously improve these LLM-backed systems? How do we improve the UX? How do we improve the model deployment and the AI reliability, the responsible AI, and things like that? So traditional app monitoring, again, we just talked about, is our very CPU and memory focus, or CDM, CPU disk memory. They're talking about, is my CPU too much? Is my disk space too low? Is my network bandwidth not enough? are my users getting like 4xx errors? Or is there any general slowness in the performance of applications, right? So these are the things that we are talking when we are talking traditional monitoring. And of course, availability, a traditional application most likely would be either up or down. Now, obviously, there will be a component of resiliency and backup and things like that. But let's say I have a web app that is deployed on a particular endpoint. So if I hit that endpoint, I either reach the application or I don't. Right? So that is the uptime and availability aspect of it. And it's deterministic and it's resource based, right? So deterministic in the sense that we know what to expect. We know what kind of input is going to be, acceptable for the application. So it is, if it's not that, it is not going to accept it at all. We know how the internal processing of that input is going to happen inside the application, and we know what output, exact output that it is going to, it is going to produce. And all of this is resource based in the sense that we know if CPU is high, the performance is going to go low. If we know that the latency is high, then the application is going to perform slowly. So it is resource based. If I have ample amount of resources available to run my application, most likely your applications are going to run smooth and they're going to run fast. And then tools and signals. So again, since this have been around for a long time, we have different ways to run traditional applications like the IaaS, PaaS, SaaS, things like that. So these platforms where you're hosting these applications, a lot of the times they are already equipped with their own ecosystems. Like in case of Azure, we have Azure Monitor. So if you have deployed your applications in here, it is automatically being monitored for the basic signals like CPU, memory, network. But on the other hand, the application powered by Gen AI has a different flow. So one, you've got the prompt submitted by the user or by another system or another agent, whatever. So once you get this prompt then let's say starts the Gen AI component of your application. Then these are converted into tokens, right? So tokens are the transaction units, let's say, for in the way that the LLM deals with the data. Whatever input that it receives, it is going to tokenize it. It is going to split it into smaller tokens and then process it. And then, of course, the cost generated is directly proportional to the amount of tokens that your application is providing. So in this way, also it is quite it's a bit different from traditional apps that it becomes really important to budget for cost right from the design phase of your applications. Now, there are some things to remember. The prompt size, of course, will matter. The bigger the prompt, more tokens you're going to have to process. And again, remember that the cost of an AI application depends directly on how many tokens you're consuming. So we have to be very careful of when we are talking about or when we are designing for cost. Make sure that your cost, you can like reasonably predict what your cost is going to. Now you cannot obviously pinpoint to the exact number, but within the range. A response quality drift, this is another challenge that is unique to LLMs, that it is not always going to hard fail. It might just soft fail in many cases, that over time, slowly as your context accumulates. Now this context may be good, this context may be bad, but as this accumulates, it is going to deviate a little bit from the standard output that it is supposed to give you. So you have to make sure that you are evaluating for the response quality drift of your LLM applications as well. Now, how do we, in the context of Azure OpenAI in particular, how do we monitor these things? Now, Azure, like we said, already has a robust observability platform, at least when it comes to the infra side of it. So we've got Azure Monitor. And Azure Monitor does have Azure OpenAI telemetry for all the instances as you deploy it. It already has collecting some platform metrics. You can also collect additional logs using diagnostic settings and things like that. So it is as a baseline, you already have some data to go off of. Alerts and diagnostics. The Azure Monitor already gives you the ability to set up alerts at different levels of your applications, right? So you can set up for infrastructure, you can set it up for availability, you can set it up for performance, things like that. So you make sure that we have got alerts that are robust and that are distributed along the length of your architecture of your application. Dependency tracing, this is basically how you monitor the user journey, the sessions in your applications, and how is a user navigating your application, let's say, or which area of the applications is most prone to errors, things like that. So these are already logged into your distributed tracing in App Insights. And on top of that, you can also add custom telemetry. So this default telemetry works fantastic, but it is not enough. So when your application is super specific, you're designed to do one particular thing, you may want to have additional insights, additional telemetry to one operation, or just make it easier for you in the future to troubleshoot something, right? So if your application is verbose, then it becomes quite easy for you as a developer or as a troubleshooter to actually pinpoint to the exact error. Yeah, this is basically what we talked about. Native metrics limitations. It's not the best, but it does come out of the box. And so if you want to, it is very low effort, of course, since you don't really have to do much. But it also has its limitations in the case that it is specifically in the case of AI apps, it lacks things like prompt versioning, which is just basically how your prompt evolves over time in your application, and then semantic context tracing, which is again basically how your the meaning of your prompt evolves along with the words that are used for prompting, right? So you don't really get any conversation level insights as well, right? So if I, as a user, having a conversation with a co-pilot or with a chatbot, I will get a high level summary of, okay, these many tokens were consumed in this application, or the user gave a thumbs up or a thumbs down to this application, or they, random things like that, or these tools were called, blah, 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 this was the latency, etc. But it is very basic. It is not going to give you, so it will give you at the session level, maybe at the highest, but it's not going to give you at the conversation level. Depending on how your application is hosted, or depending on where your agent is hosted, you can have it hosted on like Azure, if you're making it using AI Foundry or Copilot, things like that. But you can also host it, self on your self systems. So where you're hosting your application, your agents also determines what and how you can monitor it. And we talked about Azure Monitor quite a lot. So what are some of the other observability tools and frameworks that you can use? There are a couple of popular ones, LangChain being one of them. So now we are moving a little bit more towards the LLM observability other than the infrastructure observability, right? So in the beginning, do you remember we talked about two components of observability for an AI system, which is the infra part, which deals with the application itself, the browser and the resources like the CPU, disk memory, network throughput, this and that. And then we've got things like prompt drift, response drift, tokens used, tool called, tool failure, and the things that are very specific to the functioning of an LLM. So LangChain is a popular tool for tracing the insights of your LLM application, right? So application insights will actually just treat an API call to LLM as like a simple single API call. And then it comes back with the response that the LLM system has given. But with LangChain, you can actually see what's been happening inside the LLM. So this will basically help you identify as to how many tokens are being used at each step of LLM operations, what is the cost at each step of the operations, and what is the latency, what is the where is the scope for improvement, you can do this using or you can rather monitor this or identify this using things like LangChain. And the other popular observability platform for LLMs would be LangFuse. This is again where all the I don't want to repeat it again, but all the metrics that are very specific to the processing of LLMs. This is where LangFuse is what you will use to monitor them, to identify the performance and to troubleshoot what's been happening inside the LLM rather than at the application level. So with all that, this is basically, again, I know this has been really, really quick. There's a lot more, much lengthier conversation that we can have about this, and hopefully we'll have it in a longer session, maybe like 40-45-minute session. But for this one, I hope I gave you some useful tips, some useful insights as to what makes in observability for an AI system, how it is different from the traditional systems, and what tools and what frameworks, etc., that you can use to monitor those. Just to give you a quick recap, this is a Gen AI specific focus. There are new terminologies, new things, new concepts that come into play when you are monitoring a Gen AI system. So we have to track the token usage, prompt patterns, model behavior beyond traditional app metrics. Extend observability, so you have to combine Azure metrics with custom telemetry and select third-party tools. Again, like I said, Azure Monitor is an excellent starting point. By all means, do start with that. Extend it as much as you can, and when you think you are at the end of customizability for Azure Monitor, or you are simply not getting the data that you want, which is hidden inside the LLM layer, then you go for other things like LangFuse, LangChain, and things like that. Mind the gaps again, identify blind spots of your application, some black boxes that you really don't have observability into. And then ultimately the outcomes to drive here are better cost control, higher response quality, compliance, and reliable deployments, right? So cost, the biggest challenge of monitoring an AI system, because again, remember that you can get different metrics, you can get technical numbers sort of a system, some telemetry, you can get it, but this is directly impacted by the number of tokens that you are processing. And so it becomes really, really important for you to control the model behavior, to control the input and control the output, and how we get there. And so these are just basically some things, some gotchas that you really should be careful about. But thank you again for joining me. Have a nice day.
That was great, Frank.
Yeah.
Okay.
That was first
I thought
time
I wasn't hearing you.
two videos of people.
Yeah, that's cool.
The last guy, Samir, he's in India, and it was kind of like early 1 o'clock in the morning.
Yeah.
So it was.
That's what I was concerned about with Steven's last, the MVP or sorry MCT event that Steven did it was on a day where I thought I was going to be busy, and I ended up just repurposing the video because I had recorded a video with responses, but then showed up in person.
Yeah. Very good.
Yeah.
Oh yeah, we're
great to see you.
So I'm just going to end the live stream. Thanks everybody for joining us. We'll be back here again next week. On the 30th, I think we have Precious is coming on, a woman speaker, next week doing her debut. So we'll be looking forward to that. So thanks everyone. See you again next week.
Take care, everybody.